Hey guys, Mr. Jenkins here with lesson 4.5. It's called Quadratic Equations, and this is the last lesson of the first unit of Chapter 4. So if you'll recall, I said that we would cover Chapter 4 as two separate kind of units. So we'll have a unit test. We'll start to study for that after this lesson. So we've talked a lot about quadratics. In the first two lessons, we learned how to graph them. And in lesson 1, we learned how to graph or write equations in vertex form. Then we looked at standard form in 4.2. And in 4.4, we took a more algebraic look at quadratic expressions and how to factor them. All right, so this kind of ties it all together. And that was all kind of leading up to being able to solve quadratic equations. So now we're throwing in an equal sign, and we're gonna see some of the ways that changes, what we look at as far as quote doing the problems. Our learning target is I can solve quadratic equations by factoring and graphing. So simple enough. Vocab words are solution, 0, x-intercept. I would also throw in the word root. And those are all basically synonyms of each other, okay? Solution, 0, x-intercepts, and roots all basically mean the same thing for all intents and purposes. All right, so anyways, we'll go ahead and get to the examples. Example 1 is about kind of solving by graphing. So I know this is kind of hard to see, so I'll read it. This says the solutions to, well, let's see. Yeah, let me go ahead and read this. The solutions to x squared plus x minus 6 equal 0. It says, well, we're finding the solutions to that equation, okay? So basically, if I punch y equals this, y equals x squared plus x minus 6, I get this graph, all right? I get this graph right here, and you can just take my word for that, all right? So what's important, what we need to look at are, the x-intercepts, aka the zeros, aka the solutions, right? So x-intercepts are really the most important thing. All right, so it looks like we have an x-intercept at -3, 0. And also at 2, 0. Those are my x-intercepts, and so those are also my solutions, all right? So I know just by looking at that graph that the solutions to this are x equals -3 and also x equals +2, all right? And you can put that in set notation. I'm okay with just writing it like that. The math book might say x equals, and then put it in brackets, -3, +2. And so, just to show you that algebraically holds, let's just sub those in and just confirm that, right? So, remember, we're saying these are the two solutions to this equation. All right, so I'll sub in the -3 first. So -3 squared plus -3 and -6 is supposed to equal 0, and you see that it does, and we'll get the same result when we sub in the 2. All right, so 2 squared. Notice I didn't put that in parentheses because 2 is positive, so you just have to be careful when the base is negative. You do need to put that in parentheses. So plus x, so +2, and then -6. Is also 0. So you can see that those are actually the solutions. Okay, and then they show us another example that has x-intercepts or zeros at x equals 3 and x equals 5. On that note, let's do one that's not already graphed for us, or maybe two that aren't already graphed for us. All right, so it says use your graphing calculator, find the zeros of the following functions, and round each answer to, it says 2 decimal places, so the nearest hundredth as needed. Let me zoom this in just so You might be able to see it on your screen. Our first equation is 3x squared minus 24x plus 45. Just of note here, you could factor out a 3 just to make the number smaller, but we'll just kind of keep it as is. So our first step is we're going to graph f of x or y equals 3x squared minus 24x plus 45. And this is where I start to use my graphing calculator. There's a nice step-by-step here of what to do. I'll just kind of talk you through it. So I'm going to clear out. I went to y equals. I'm going to clear that out because we want that to be blank. So we'll go 3x squared minus 24x plus 45. All right, now I'm just going to kind of look at my graph and see whatever I see. Okay, so just some things to note, review from the first lesson. It would make sense that this is a parabola that opens upward, right? Because a is positive. It's also vertically stretched because a equals 3. So anyways, it appears when I look at my graph that I have x-intercepts at 3, 0, and 5, 0. All right, so you do want to confirm because, you know, that could be like 3.05 or 2.95 or something like that. So let's just go to our table and make sure that it does cross at 3, 0, and 5, 0. All right, so this right here shows me that it goes through 3, 0. And this one through 5, 0. So sometimes it's as easy as just kind of looking at the graph there. So that one was pretty easy once we kind of punched it in. So just to recap, we saw on our graph, I'll go back to that while I'm writing it. We saw on our graph that we had x-intercepts at 3, 0, and 5, 0. And so those are my two solutions, the x coordinates of the x-intercepts. So x equals 3 and 5. I don't care if you use the little brackets there. If you want to say x equals 3 and x equals 5, that's fine. If you just want to say x equals 3, 5, I think that's what it says on my notes or something like that. But there you go. In other words, if we sub in 3, that will make that equation true. If we sub in 5, same deal. All right, so usually I leave the other one for you, but I do want to show you something else here because this one is a little bit trickier. So kind of skipping ahead, I'm going to graph y equals 3x squared plus 2x minus 2. 3x squared plus 2x minus 2. All right, now you can kind of tell here that, well, it doesn't go through -1, 0. It doesn't go through 1, 0. So now it's like your guess is as good as mine as to where it crosses, right? But you don't want to just eye it. You want to use the 0 function on your calculator, which is outlined on these notes, okay? But I'll go ahead and take you through it. And remember, you can always rewind on this stuff too, okay? So what we want to do is go to calc, which is second trace. And we want to find the zeros, right? So that's option 2. Okay, so what we have to do is you have to basically tell it where to look, all right? So we want to tell it to look right here first. So it says left bound. So that's anywhere that's to the left of that 0. So I'm hitting the left arrow until it gets to the left. So I can hit enter here. I could move it further left, but I'm going to go ahead and hit enter. So now I have my left bound. Now it wants the right bound. So now we go to the right of it, anywhere, right? And I know I'm to the right of it once I go, you know, underneath the y-axis there. So I'll go ahead and hit enter. And then you have to hit enter one more time, okay? You have to hit enter the last time, and it will tell you, there you go. negative 1.21525. Now we have that number where we can round it to the nearest hundredth, which was in the directions. So we'll call that rounded to the nearest hundredth, an x-intercept of about negative 1.22, 0. And then we'll repeat that process one more time. Okay, so so then we want to go back into calc. So again, second trace, again option 2, and now we're going to find the other 0. So first we want the left bound. I'm going to scoot over a little bit, and I'm to the left of it still. I could get a little closer if I needed. I know I'm still to the left of it because I'm below the y-axis. So I'm going to hit enter. I'm going to move to the right of it. As soon as I cross the y-axis, I'm to the right of it. You might want to move a couple more spaces just so it's more obvious, just to show you that it doesn't matter. Hit enter, enter again, and there you go, 0.5485, da 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 da. So, and 0.55, 0. So those are my two x-intercepts, and then so we would say x is approximately negative 1.22 and x is approximately 0.55. As far as on Desmos, I'm not sure how that feature works, okay? Actually, you know what? Desmos shows you the x-intercepts, so they're probably already going to be highlighted for you. If somebody could let me know how that works, I'd appreciate it. All right, now moving on to what is another approach. The other approach would be that we could solve by factoring, okay? I told you guys that factoring would show up a whole bunch. And so now you'll start to see that is true, okay? So same types of equations. In other words, I could solve B1 just by punching in x squared minus 5x plus 6 and looking for the intercepts. So that'd be a good way to check your answers maybe, but we want to be able to solve by factoring as well, okay? That would be one of those things on a test where you would have to show your work a certain way. All right, so first of all, why does that help, right? So when we factor a quadratic expression, we're basically writing it as the product of two linear factors, right? And linear factors are easy to solve, right? A linear equation, we can all solve those, hopefully at this point kind of in our sleep, right? So that's the gist of why it works. Now let's see it in practice. So I'm going to try to factor the left side of my equation. All right, so I'm thinking what is a combination that's going to multiply to give me positive 6, add to give me negative 5. That would be negative 3 and negative 2. So I'm factoring this out to x minus 3 times x minus 2 equals 0. I haven't changed anything. I just changed the way it looked. I just rewrote the left side in a different way. But now we recall kind of a fundamental thing, the zero product property. If I multiply two numbers and either one equals 0, then that is going to solve my equation because 0 times anything equals 0. So essentially what we're left with here is two just very simple equations. So in your mind, you're thinking, I'm going to solve x minus 3 equals 0. Which tells me that x equals 3. And also x minus 2 equals 0 tells me that x equals 2. Okay, so again, we want those linear factors because we have two little mini equations that we can solve very easily. And eventually you want to be able to get from here straight to here without really showing that middle step. Okay, so I'm just showing these kind of in an elementary way right now. Okay. Looking at B2, we have an added step. You don't want to try to obviously factor this as is. You want it in standard form, which would mean I want the C term over here with the A and the B terms. Okay, so we're going to rewrite this on B2 as is. It says x squared minus 7x equals negative 12. And we're going to rewrite as x squared minus 7x plus 12 equals 0. Now we're in standard form, and now we're thinking we're going to factor the left side. So what multiplies to 12 adds to negative 7. The answer to that is negative 3 and negative 4. So we go x minus 3 times x minus 4 equals 0. And then we have x minus 3 equals 0. So we know from this x equals 3. And then our other kind of root is x minus 4. So that tells me that x also equals 4. All right. And again, you can always double check. Well, you could double check multiple ways. You could double check algebraically, meaning you can sub in 3, 3, and see if you get 12. Sub in 4, 4, see if you get negative 12. Or, you know, here would be maybe a more creative approach to checking your answers. So, you know, maybe I graph this on my graphing calculator real quick and just see if I have x-intercepts at 3 and 4. So let's do that real quick. X squared minus 7x plus 12. Remember, you want your standard form version. Look at the graph and see if it matches up. All right, and it looks like it does. It crosses at 3, 0, crosses at 4, 0. Okay, so let me leave B3 for you, and then I'll just show B4 and then be done with it for this lesson. But remember, on B3, you can always check on the filled out notes for these solutions. That'd be another way you could check your answer in this scenario. All right, so looking at B4, B4 looks a little bit different. So, you know, what can I do first? I can factor out a GCF, right? So the GCF of these two terms is 2x. So let's see what happens when I factor out a 2x. That'd be 2x times the quantity, 2x plus 3 equals 0. Now, we had some in the last lesson where, you know, I factor out a GCF and then I'm still left with a quadratic expression in the parentheses. But not here. You know, once I factored out a 2x, I'm left with 2x is a linear factor, 2x plus 3 is a linear factor. So then I know I'm finished and I can easily solve this, right? A lot of people on this one would just get x equals, you know, negative 3/2, which is the solution to that part, and they'll forget to do this part. But don't forget here, this is one of your two linear factors, even though it's not in parentheses, right? So for this one, you're thinking 2x equals 0, right? So it's really simple to solve, but again, people forget it. So just kind of warning you there. And then the other one, you got 2x plus 3 equals 0. So move over the plus 3, that's 2x equals negative 3. Divide by 2, we get x equals negative 3/2 or negative 1.5. All right, and I believe that is that. All right, so learning to solve these by graphing and by factoring, which I think you've seen before in Algebra 1, but this is important stuff. So just a reminder, this is our last lesson of this part of the chapter. So we'll start to get into study guides, Math Excel due dates, all that good and fun stuff. As always, hope this video helps. Let me know if you guys have any questions, and have a good one.